we're going to start talking about our first method for solving quadratic equations, which is solving by taking the square root. This is our easiest method probably, but it also only works in certain conditions. So this is not a method that you can use whenever you want. We can only use this method when you do not have an x term. So in that ax squared plus bx plus c equals 0, our standard form, the b has to be 0. There's a couple of other cases where it can work, and we'll look at some of those when it is not in standard form. Essentially, it's going to be able to work when you can isolate the squared portion. So when you can get that x squared by itself using our inverses, and nothing but numbers on the other side, that's key, that's when you can use this method. So inverses, addition and subtraction are inverses, multiplication and division are inverses, and then we'll take the square root, because squaring and square rooting are inverses. And then, if we can, we're going to plug in to check our answer. Sometimes the plugging in is going to be a little bit above our skill level, and in those cases we'll just double check our work to make sure we didn't make any mistakes. Now, this very important note, you must use plus or minus when you take the square root of both sides of an equation. We're going to talk about that when we start solving, but the reason this is true, if I square 5, I get 25. If I square negative 5, I also get 25. So because squaring a positive 5 and squaring a negative 5 both give you a positive 25, when I take the square root, I don't know if the initial value was the positive, which we also call the principal square root, or the negative square root. So I have to include them both in my answer. Remember, when you have an x squared, you're looking for two answers anyway. All right, let's take a look at some examples. So we're going to go through and we're going to do the examples on the left column, and then in class we're going to do the examples on the right column. We're going to work a lot of examples because the more examples we work, the more likely we are to get the process. Okay, so my first step, first I should say I've got an x squared, I've got a constant. I don't have just an x, so I know I can use this method. So here's my x squared right here. I want to get the x squared by itself. It's being multiplied by 2, so to get it by itself I'm going to divide by 2, because multiplication and division are inverses of one another. So I get x squared equals 4. Now, once I have the x squared isolated, so I've got the x squared on one side by itself, everything else on the other side. Once I have the x squared isolated, I'm going to take the square root. And the reason I'm going to take the square root is because that's the inverse operation to squaring. So if I've got x squared and I want the x by itself, I'm going to take the square root. So my answer here is going to be x equals square root of 4 is 2, but don't forget we need the positive and the negative. So my two solutions here are 2 and negative 2. This plus or minus is just a more concise way to write that. Positive 2 and negative 2. Those are my two answers. Again, the reason I need the plus or minus is because if I do 2 squared, I get 4. And if I do negative 2 squared, I get 4. With an x squared, we expect two answers. So if I'm not getting two answers, I probably forgot my plus or minus. Now to plug in and check. So I'm done. That's my answer right there. But if I want to do a check, I come back to my original. I do 2 times 2 squared equals 8. So I'm plugging 2 in for the x. I do my exponent. And then once I do my multiplication, I'll see that that's a true statement. If I plug in negative 2, I do my exponent, and then when I do my multiplication, I'll see that that is also a true statement. So my solutions, because I expect 2 with the x squared, to 2x squared equals 8 are positive 2 and negative 2. We're going to go down and look at example 3. In example 3, I have 3x squared minus 15 equals 0. So I've got an x squared, I've got a constant, I've got a constant, I've got no x. So I can use this method. Now, this time I've got 2 steps to get my x squared by itself. And basically it's a 2-step equation like when we were doing linear, except I'm still going to have to take the square root in the end. So to get rid of, or to isolate the x squared, I first need to get rid of this minus 15. So I'm going to add 15 to both sides. And then I need to get rid of the 3. The opposite of multiplying by 3 is dividing by 3. So I'm going to divide both sides by 3. Now that I have my x squared isolated, so my x squared is by itself. On the other side, I just have numbers. If I have variables over here, there's a problem. So x squared is by itself. On the other side is just numbers. To undo a square, I square root. Squaring and square rooting are inverses of one another. So I'm going to square root both sides. Now some of you are probably thinking, I can't take the square root of 5. Actually, you can. It's not a perfect square, so when you do it, you're going to get a decimal. It's not going to be a nice, pretty integer. So you can either approximate, or you can just write your answer as the square root of 5. So if you were to write it just as the square root of 5, which is the more precise way to write it, taking that square root, I would get x equals the square root of 5. Don't forget the plus or minus. I could also use my calculator, hit 5 in the square root, and it gives me 2.2360679. I'm going to go to 2 decimal places. So again, plus or minus 2.24. Rounding correctly, 2.24. Now, I'm usually going to tell you which way I want your answer. If I say do not round, I want it written like this, x equals plus or minus the square root of 5. If I say round to 2 decimal places or the hundredths place, it'll look like this. I might say the tenths place, that's 1 decimal place. So just follow the instructions for how to write your answer. This one we're not quite ready to plug in and check. So we would just check our work real quick, make sure we didn't make any mistakes, but we didn't, so we're all good there. All right, we're going to take a look at example 5. So example 5 looks quite a bit different than the others because I don't just have x squared, I've got x minus 2 squared. Notice that this entire side is being squared. This whole side, the whole thing. When that happens, I can just go ahead and take the square root. Because it's the entire side being squared, I can do the square root of both sides. Now, I've got to be careful. The square root of x minus 2 squared, those two things are going to undo each other. They're inverses. So that's going to leave me with just x minus 2. And then the square root of 36 is 6. Don't forget your plus or minus. Plus or minus 6. So I've got to deal with the positive and the negative. So whenever I take the square root of both sides, I have to use plus or minus. Now, on the others, I was done once I took the square root. But notice this time I don't quite have my x by itself. So this one's just a little bit different. I could still take the square root because the whole side was being squared. But now it's just a little bit different. What I have to do is write it out as 2 equations. The x minus 2 is 6, and the x minus 2 is negative 6. And that gives me 2 equations to solve. So I need to add 2 to both sides. There's one of my solutions. Add 2 to both sides. Signs are different, so I subtract and keep the sign of the larger. There's my other solution. So I'm going to run through this again. This whole side was being squared. So to undo a squared, I can take the square root of both sides. Don't forget the plus or minus. Then I wasn't done because that x isn't by itself, and that's our goal when we're solving. We want x equals. So I'm going to split this into the two equations that they are. X minus 2 equals 6, x minus 2 equals negative 6, and solve each of those. I'm going to check my answers, but I'm going to do it in my head. I'm going to say it out loud, but I'm not going to write it down. If I plug 8 in, I get 8 minus 2 is 6. 6 squared is 36. That gives me a true statement. If I plug negative 4 in, negative 4 minus 2 is negative 6. Negative 6 squared is 36. So I get another true statement there. We are going to do the even ones together in class, and then we will continue practicing.